So here I've summarized the information from example 20.2. So the unemployment benefits are $50 for each time period. The initial offer of wage is $60. And then in time period 2, there's a 50% probability the worker will get an offer of $80 and a 50% probability the worker will get an offer of $40. We're only going to look at 2 time periods today, and we're going to let the discount factor or discount rate be equal to 0.9. So the question we want to ask is, will the worker accept the job offer of $60? Well, let's look at this. So the value of taking the offer of $60 is equal to, they would get $60 in the first time period plus beta times $60 in the second time period. So this is equal to 60 plus 54, which is 0.9 times 60. And so they would get a total value of $114. Now, what if they reject? So this is if they accept. What if they reject the offer? Then we would want to first calculate what is the expected value of wage in time period 2. So it's 1/2 times 80 plus 1/2 times 40. We would expect to get an offer of $60. So therefore, their utility that they would get would be $50 in the first time period, because that's what they reject, or they reject the offer and get the unemployment benefit, plus beta times the expected value of wages in the second time period, which is 60. So this is 50 plus 54, which is equal to 104. And so in this, it's clear to see that the individual is better off by taking the offer than they would rejecting the offer, taking unemployment benefits, and searching again. Right, now, we can look at different variations of this problem. Is what would happen if the distribution of wages were to change? What would happen if the benefit were to change? What would happen if the discount rate were to change? And even what would happen if we were in a different time period? And so those are things that we can look at within this model to identify whether individuals will accept an offer or continue searching. And that's the main goal of the McCall Job Search Model.